Hello, everyone. Welcome to group number 1, sets and whole numbers. Today we will be discussing those topics. And before we begin, I was actually looking for math jokes, but for some reason, whenever I looked for trigonometry jokes, they were all too graphic. Anyway, today I'll be speaking about and discussing sets and operations on sets. So let's get started. So, understanding sets, and operations on sets. The definition of a set is a number of things of the same kind that belong or are used together. A few examples of sets, and this is completely unrelated to anything. It could be anything random between colors, shapes, or even vowels, like example number 1, vowels in the English alphabet. So we would write that set as V equals A, E, I, O, U. Another example we can use as a set is first 5 odd numbers, which I just chose to name it a set X, which is 1, 3, 5, 7, and 9. Furthermore, we're going to be talking about the symbols because the symbols are very important when it comes to sets and solving them. So the first one, which looks like a U, is used as a union. It's called a union symbol between 2 or more sets, and it stands for and, which I think that whenever you're thinking about solving sets and stuff, knowing the word that it stands for, which is and, can be very helpful, which I will be showing you in a little bit. The little U that looks like it's upside down is for intersection between 2 or more sets, and it can stand for the word or. Another one is this, which is essentially used to put like sets. That's where you put your letters, your numbers, your shapes, your colors, whatever you want to put in your set goes in between those. But also whenever you're solving something and it gives you an empty set or a null set, that's what it means. It's like the little brackets with nothing in the middle, which is pretty easy to remember, I guess. The little slant means relative complement. It is used as minus. So if you put it between 2 sets, it would be set, let's say, set number X, the relative complement of B. And it would just mean that you're subtracting B minus X. And so now we are going to go ahead and start. I'm going to start showing you what it is. So first of all, we are going to start. Let me clear this out first. We are going to choose 2 sets to intersect. And so the first one, I'm just going to choose some random one, which I'm going to say set X. And I'm going to put in here in these little brackets, I'm going to put 4, 5, 7, 9. So that's going to be set X. Then for, let's say, name it set Y, we are going to have nothing in there. So then we are going to be using intersect, the intersect sign. So then this is going to be our question, and you're going to have to tell me the answer of this. So X intersect in Y. So we said, my bad, that the intersect stands for or. So pretty much what you're doing here is saying what numbers are shared in X and in Y. What numbers in X are also in Y. And since we have, and let me show this spotlight. Since we're looking at this and it only has and there's nothing in here, that means that our answer for X intersects Y is going to be an empty set. or a null set? So that is the answer for this one is this. Now, we are going to do another set just so that you can see union being used. So now we are going to use, let's say, set A. We're going to call this set A. And our set A is going to contain numbers 1, 6, 2, 3, 14. That is going to be our set A. And for our set B, sorry, this is too bright. We are going to put 2, 9, 13, 1. So that's going to be our 2 sets that we're using. I'm not going to use more because it'll take too much time. So now we are using this. What is that? We said that means union, and it can also mean and. So essentially what we're trying to do whenever we write, let me see, whenever we write A union B, what is that? So we are saying A, whatever set A has and B has. So what we're doing is the union is putting them together. So how we write this, our answer for this would be 1. We start with our set A, and we write everything that's in set A. 1, 6, 2, 3, 14. Then we continue with our set B, whatever's in B. So B has number 2, and since we don't have 2 already, we write it down in here. Our set B has 9, and we haven't written a 9 in here, so we write a 9. Our set B has a 13. We do not have a 13, so we write it in here. However, our set B does have a 1, but also our set A has a 1, and we have already written it in here, so that is our answer for this. So A union of B is 1, 6, 2, 3, 14, 2. Oh, I did a mistake, actually. I didn't see that. We already have 2, so we do not write 2. So would be 1, 6, 2, 3, 14, 9, and 13, because our U stands for and. So that's putting those 2 numbers together. Anyway, I hope you guys learned what a set is and how you can use it and how to use our symbols. Now, next up is Cat Knight with Venn diagrams.
Hey, thanks, Ruth. I actually have a question for you real quick.
Yes?
Why was the math book so sad?
I don't know, Kat. Why?
Because it had too many problems. But fortunately, Group 1 is here to help with that. So today I'm going to be explaining Venn diagrams, which has been actually greatly introduced by Ruth in her description of sets, because we can just tie it right in there, because a Venn diagram is basically just a representation of a set. So with that, I'm going to set up a problem and show you how I would put it in a Venn diagram. Now, the thing with Venn diagrams is we can actually use many different types. You can use many different circles, but for ours, we are just going to use 2 to keep it simple. So for first, we got a set of numbers, and I just chose to use 1 through 15. So now we're going to separate our sets, and we're going to do it into multiples of 2s and 3s, and we're going to separate that off into a Venn diagram. So what should we do first when we know how we're going to divide our set of numbers? Well, first we should figure out which category each number falls into. So if we've got the multiples of 2s and the multiples of 3s, we can go ahead and write them out in a list. So multiples of 2, which is 2, 4, 6, 8, 10, 12, and 14. And then we have our multiples of 3, which is 3, 6, 9, 12, and 15. I did not add that on the end. And then here we have a Venn diagram set up. This is where you're actually about to fill it up with information. So here we have written down our sets of numbers again. We've got 1 through 15, our multiples of 2, and our multiples of 3. So our multiples of 2 are going to go into set 1, and our multiples of 3 are going to go into set 2. So I went ahead and did that. Here we've got 2, 4, 8, 10, and 14 into set 1. Set 2 has 3, 9, and 15. Now, if you notice, I'm missing some numbers in both of these that are not on this list over here on the right. I do not have 6 and 12 on set 1, but if you notice, I'm also missing those exact same numbers on set 2. And that is because those are numbers that they share, so that one in the middle because they are numbers that are similar to each other in the set. They share the same criteria that this set was divided into. Now, we're also missing numbers that are not, they don't fit in any of these circles. So what they would do is we'd actually put them outside the circle. I set them right here. These are considered in the universe. They are not, they don't fit any of the criteria, but they're still in our set of numbers. So that is all I have for Venn diagrams. So next we have Crystal Lambert with one-to-one correspondence.
Thank you, Kat. Hey, Kat, how many monsters are good at math?
I don't know, Crystal. How many monsters are good at math?
None, unless you count Dracula. Okay, so now for some one-to-one correspondence. So, how many, did I share us? There we go. How many of you know how to count? Well, today we're going to start by counting my blocks. And let's see, we have 1, 2, 3, 4, 5, 6. Ooh. Let's back up a little bit. Okay, we have 6 blocks. And how do we know that there are 6? We know this because 6 was the last number we said. Are you ready to learn a fancy word? Cardinal number is a fancy way of saying how many. How many are in our set? There are 6 blocks in our set because 6 was the last number said when we counted our blocks. Now, what if I change our blocks and stack them and make a different arrangement, a pyramid? Let's count them again. And we have 1, 2, 3, 4, 5, 6. Now we know that even if we put our blocks in a different order, we still have the same number of blocks. Now we have the same blocks, but they have stars on them. Can you tell me how many stars there are? Anybody have a guess? There are 6 stars, and we know this without even counting because there are the same number of stars as blocks. And you ready for another fancy word?
Yes.
It is equivalent sets. Do you know what that means? That is a fancy way of saying they match. 1 star is matched to 1 block. So since we already counted 6 blocks, we automatically know there are 6 stars. Now, I bet you kind of already know what this is. We have words like first, second, third, and fourth. When do we use these words, and what does it mean? Well, these words are called ordinal numbers, and it tells us which order something is in. And when do we use words like first, second, third? Do y'all know when y'all use those words?
Whenever we're counting?
Kind of when we're counting, and a lot of times it's as kindergartners, we use it when we play games and when we're racing. We know who came in first place and second place. This tells us which order it is in. So the number 1 block is the first block, and the second block is the number 2 block, and that continues with every number that you progress with. And that is all we have for one-to-one correspondence and equivalent sets. Now Laura will show us how to use whole numbers.
Thank you, Crystal, for that wonderful presentation. I have a quick question for you. You know why 8 wasn't friends with 3?
Why?
Because 3 was odd. So I'm going to introduce you guys on representing whole numbers and how you order whole numbers, and I'm going to show pictures and a number line on comparing whole numbers. So representing whole numbers. You're ordering whole numbers, so if B is more than A, the expression is B is greater than A. If A is less than B, the expression is A is less than B. But if B and A are equal, they're the same number, the expression is B is equal to A. So I'm going to show you from where I was with the apples. All right, so here's our problem. If Lila has 3 apples and Alexia has 5, we want to know who has more apples. So we're going to use our pictures. Here's Lila's 3 apples, and here's Alexia's 5 apples. If you line them up like this, you can see from the pictures that Alexia has more apples than Lila. So we can show this by using the expression 5 is greater than 3. Now we're going to use a number line to show the order of whole numbers. So you want to start a number line. It doesn't start with 1, it starts with 0. So we're going to use number 4 and number 8. Now the number you get to first is the smaller number. So we have 4 is our first number, so that means it's going to be smaller than 8. So the expression is 4 is less than 8. So that's my presentation on comparing whole numbers. Thank you for watching Group 1's presentations of sets and whole numbers. I hope you guys have learned a little something.
Bye.